Good morning. I'm Dominic Threaton, and we are Tube Escort LLC. Now, first, I want you to close your eyes for me. Now, imagine you get up in the morning, you get dressed, you get in your car, you're driving down the road, you get to the first stop sign you get to every morning, take your foot off the brake, foot on the gas, and then all of a sudden, black. You don't remember anything. You have no idea what's going on. The next thing that you wake up to is a bunch of doctors being over your face, and you want to ask what's going on. You're freaking out, but you're in a lot of pain, and you can't really get anything out because you can't really catch your breath. The doctors let you know that to calm down, and they actually have a collapsed lung. So what's happening here is they're explaining that they're gonna have to insert a big tube into that chest cavity to allow for re-expansion of your lung. So they have to go in and insert a huge tube right in between your ribs, which is not gonna be very comfortable. So they go in to do this procedure and it doesn't go right. They throw this chest tube in there, and instead of placing it in the optimal position, they accidentally puncture your lung. So now they have to do a whole nother procedure where it's a lot more invasive. They have to go suture up your lung and then put in another one of these tubes for you then to lay in bed. This obviously costs a lot more money, and in addition, it's going to cost a lot more pain to the patient. And the physician also is going to be used a lot longer because now he has to do a whole nother procedure that he wasn't planning on doing. So this problem, there's about 1 million of these chest tubes placed every single year in the US alone. Of these 1 million, there's a 36% complication rate. That's 360,000 cases that have some sort of complication, either puncturing a lung or misplacement of the chest tube that then has to be replaced in another position. Moving on to the actual procedure, what they're doing now and what's going wrong. So you have this collapsed lung, and as you can see, you have the pleural cavity, which is where your lungs sit. In order for your lungs to expand and contract, there has to be a vacuum seal. Well, whenever you have a collapsed lung, there's a breach in this vacuum seal. So they're going to put in this tube that's going to then connect to pretty much a vacuum. So you make this incision into the actual patient in between the ribs, and then using pretty much medical grade pliers, you're going to go in and blunt dissect until you get to this pleural cavity, or the space where the lungs are held. The physician's then going to stick his finger to ensure that he's in that cavity, and then he's going to grab his chest tube with the pliers and then push it into the actual space. This is where the complication comes in. So once he removes the pliers and he just has the tube and he's going to feed it into the actual space, you can tell here that he has to curve it up and put it toward the back of the patient, because the patient's going to be laying down in a bed to suck up all those fluids that might be building up. And in addition, you want to get rid of any of the air that's in that actual cavity without getting it stuck in any of these fissures that your lungs, because their lungs are made of lobes, so it's easier to get stuck in there. So of these complications, what are we looking at? We're looking at post-removal, insertional, and positional. We're not really worried about post-removal because this happens no matter how you're inserting the chest tube. This is something that we're not going to be focusing on. So as far as insertional and positional, we're looking at about 75% of those complications that we talked about before. So insertional, it's going to add $120,000 to the additional cost to the consumer or the patient. And then for positional, so like let's say that you placed it in the wrong place, you have to place another one, it's going to cost another additional $12,000 to the patient. Looking at these complications in the US, you're looking at about 300,000 cases that have insertional and positional misplacement. And you're looking at about $6 billion and $3 billion proportionally, which is a subtotal of about $9.3 billion. So what are we doing to solve this problem? As you can see here, the red portion is going to be a non-reusable portion, and the silver portion is going to be a reusable portion. So putting it all together, the physician actually takes hold here, and this part is actually going to be inserted into the body. So as before, the patient lays down and the incision is made. You insert the chest tube all the way to the tip, and then you're going to grab it with the same pliers and insert it into that cavity. Once you're in that cavity, you have a rip cord here, which the physician can pull on, which then allows this piece to bend, giving it around a 90-degree rotation. You can then feed the chest tube into this cavity, avoiding the lungs, and in addition, it gives the physician an intuitive sense of where the tube's actually going to go and allows him to place it a lot more accurately. So for our value proposition, we're looking at about a 96% success rate, which is around 960,000 cases performed successfully every year in the US. We're also looking to increase that efficiency for both the accuracy and the time in which it takes the physician. This saves the hospital money because, one, they don't have to do additional procedures that they weren't planning on doing in the first place, and two, this physician is now more available to do other procedures that were scheduled. And as we know from COVID-19, the availability of physicians is very important to hospitals and to healthcare in general. Our market opportunity. So the procedure costs around $6,000 for a base chest tube thoracostomy, which is the actual procedure. So that makes it a total US market of about $6 billion. Adding in those complications, we're looking at greater than $16 billion in the US. So what we're looking in, so our revenue potential, we're looking to open into the Northeast, specifically Pennsylvania first, and then into the Northeast, because it has such a high population density and a huge high trauma per capita, which obviously blunt force trauma of the chest, such as that car crash we talked about before, is a big deal. So $5.2 billion is a big opportunity for us in a small area. Our competitive landscape, there are two other devices which are either coming about or in the market already. As you can see here, the reactor is similar to our device, but it doesn't allow that 90-degree curvature that we allow, which we believe is going to allow that high success rate that we're looking at because of the articulation that you're allowed within the body and the degrees of freedom. And then to the right, you see the CAT guide, which is made by Pleuratech. Obviously not as good as ours because it's stuck at that 190-degree angle, whereas ours allows the insertion and then you can become whichever angle the physician would like. So looking at our milestones, in June 2020, we're looking to finish our quality assurance. So we want a fully functional, fully working, established proof of concept, which is to get there, it's going to cost around $12,000. And then we're looking into get into our patent, which we're hoping to be done by February 2021. And that's going to cost around $30,000. Once we get this, we're hoping to move into clinical trials, which can cost about $3 to $5 million, which is why we're hoping, you can see below, we're hoping to move into a license agreement with a medical device company so that they can take on some of these risks that we know if the clinical trials don't go well, we don't want all of this backlash and take on all this financial risk that's unnecessary. And then if we do get past this, we look for FDA approval, which costs about $10,000 by January 2023. For our exit strategy, we're looking at the two devices that we were talking about before. Sharp Medical Devices, which was the gun-looking one, sold to Medical Alliance for multi-million dollars. We don't know the exact values because Med Alliance is actually a private company. But Pleuratech, which was the CAT guide, which was the bendy one that was stuck at that 90-degree angle, sold to Merida Medical for $7 million and about 6% royalties for the next 15 years, which is where we think we're going to be in the ballpark of. Now looking at our financials, we're looking at a net profit around $210 for the gun itself, and then reusable part about $17. So the first 3 years, obviously we're going to be in clinical trials. We're not too worried about selling at that point. So moving into 2023, selling about 1,250 units, which we're selling 25 tubes for every 5 guns per hospital. And for this number, we're selling to about 250 hospitals, which is only an eighth of the total Northeast market. And then increasingly selling these over the next 2 years or next 3 years, we're looking at about 3.5 million at the end of year 2026. Our team is composed of 4 highly motivated and passionate bioengineering students from Temple University. And we would like to give a special thanks to Dr. LeMay for helping us through every iteration of our prototype. And also would like to thank Dr. Hendon, who is a part of Stanford Biodesign Program, now for bringing this problem to our attention. Start saving lives now and invest in Tube Escort LLC. Thank you.